Hey guys, welcome to Distance Learning Day 10. Some of you guys did really well on the last exam, so we're semi-happy about that. Yay! Okay, so some upcoming dates that you need to know are Friday, of course, is quiz day. It's going to be on Test Wizard. It'll be open between, what, we're going to do 9 and 3? 9 and 3 again, so make sure you do it during those two times, okay? Then, on Monday, you're getting a quest today that's going to be due next Monday. Mr. G is going to start rocks today. We did minerals already, which means that our rock and mineral exam will be on Wednesday. Okay, that's the day before your spring break starts. We haven't heard anything about what's going on during spring break. I'm pretty sure we're not going to be allowed to do distance learning during that time, but we haven't heard anything officially. Also, another thing we haven't heard officially is about the regents. Okay, we know nothing.
Please stop asking. When we know, you'll know.
Yeah. So, and also, guys, come to those office hours. We had 5 people come to the office hours, one of which doesn't even have either of us as an earth science student. She's in chem. Okay. So please come to office hours. I believe we're going to hold them this week, probably Thursday again. I will let you know. We'll be posting it on Google Classroom. I know you guys are having Google Classroom issues. If that happens, some of you guys did this already and it was perfect. Email us the assignment, okay? If you're having issues downloading the assignment, ask one of your friends. You guys are all on group chats. We know you're on group chats, okay? Ask one of your friends. The 2 of us are doing the same things, all right? So you can get any of your friends that have Mr. G or myself, okay? You can find out exactly what we're doing. Ask them to text it to you or airdrop it to you or whatever it is. Hopefully you guys are staying safe and staying apart, okay? That's the most important. What am I doing? Okay.
Social distancing.
See? Don't touch. Please. Okay, so, you could do like we did and get a dog. It works, all right? So just keep your distance, guys. We hope you guys are all staying safe. And please, all of this is on the regents. As of right now, you are taking the regents. Okay, either way, you're taking some sort of a final. We don't know what it's going to be, but right now you're taking the regents. So please pay attention and take this seriously. All right, bye guys.
Hey guys, so we are going to be talking about rocks like Miss G said. You know, that thing you guys thought we were going to be covering all year, and we're just getting to it now. Now, there's going to be a lot of definitions in this PowerPoint and in the ones coming up. So please make sure that if you have to, stop it, rewind it, do what you have to do to make sure that you get the proper word in. So, what is a rock? A rock is a mixture of minerals. What does that mean? It means a rock is going to be a combination of 1 or 2 or 3 or 100 different minerals put together. What minerals are inside of a rock, which is what we call mineral composition, the minerals that are inside of you, and texture, which is a little bit more than just the way that it feels. It's the appearance of the rock, it's the size of the crystals and things like that. We will talk about that, okay? But all of that has to do with where the rock formed and how the rock formed. So formation is going to lead to mineral composition, which is the minerals that are inside of it, and texture, which is the generalized appearance of the rock, categorically named. Okay? We'll talk about that in a minute. Alright guys, so the first thing we're going to talk about is the rock cycle. Now I know you guys have done this plenty of times in the past, but this one's going to be a little bit more in depth. Now, if you look on page 6 of your reference table, in the upper right-hand corner, you will see the diagram that is above. That diagram that is above is of the rock cycle. Okay? Now, I'm going to give you 2 versions of it, the black and white one from your reference table and one that's in color, which you can see now. I will be switching back and forth between the 2 of them, but they all have the same basic things. Okay? So, if we're looking at the rock cycle, you can see it's not as simple as just the straight circle that you learned about it in like 5th or 6th grade. There's a lot of interconnected parts. You can jump from one side to the other. Sometimes it doubles back, and there's a bunch of different terms in there. So we're going to go through and define each one so we know what they mean. All right, guys, so we're going to start at the bottom of the chart, down where it says magma. So magma is completely or partially molten rock that is below the Earth's surface. When the magma escapes to the Earth's surface, it becomes what we call lava. So there is a difference. Magma is below the surface, lava is above the surface. Okay, so when we're talking about magma, magma has a bunch of different things in it. It's mostly composed of small minerals, primarily silicates, the stuff that we talked about. Okay, so that would be silicon and oxygen bonded together. But magma is more than just melty rock. It actually has 3 distinct parts. It has what we call the melt, which is the liquid part. It has volatiles, which are the dissolved gases, and it has what we call crystallines, which are actually things that never melt and stay solid. So if you look at the picture now, when we talk about melt, that's usually what you think of when you think of magma. This is the liquidy stuff, the stuff that runs down, that erupts in these big fountains and looks really impressive in like disaster films and stuff like that. Okay? The volatiles are the dissolved gases, and the dissolved gases, and this is important because we're going to say it a lot, there's usually three main dissolved gases. Those dissolved gases are water vapor, which is H2O, carbon dioxide, which is CO2, and methane. Okay? You can have other things in it, sulfur dioxide and other things like that, hydrogen sulfide, but your three big ones are carbon dioxide, methane, and water vapor. Okay? A lot of the stuff that's in our atmosphere actually originally came from volcanoes. In fact, our first atmosphere came from volcanoes releasing gases, which is what we call outgassing. The picture that you see above you, which I know is a little disturbing to some of you, but all those little holes that you see used to be filled with gases. When the magma solidified, those little holes were left and it gave the rock this spongy appearance. Okay? So those little holes all represent specific gases. And then the third part is what we call the solids, the crystallines. And these are usually little bits of stuff like silica that have a very high melting point and never 100% melt into the material that it has to turn into. Now, as magma starts to cool down, it's going to crystallize. Remember, we used this word when we talked about phase changes. What does that mean, crystallize? It means solidifies. We use the term freezes when we talk about water. It means you go from a liquid to a solid. So you are losing heat. Okay? So as it begins to crystallize, it starts to form different materials. Now, what materials and what minerals are formed depend on a couple things. One, what were the ingredients in the magma to start with? And two, how long did it have to cool? The longer it has to cool, the bigger the crystals are going to be that can form. Okay? And the more complex the materials can be. If it cools quickly, it's not nearly going to have as complex or bigger crystals. So as the magma or lava cools, depending on where it is, remember, okay, it is going to solidify and it is going to turn into a igneous rock. Igneous literally meaning fire rock. Okay, igneous rocks can form in a lot of different environments, have lots of different minerals, different colors, different textures. You can have something like the rock that you see above you, which is called obsidian, which would form from lava very quickly, cooling on the Earth's surface. Or you could have something like this picture, which is granite, which forms from lava cooling much, much slower. We'll get into the particulars of these different types of rocks later. All right, it's at this point that the chart starts to get a little wonky. Stuff starts to cross all over the place. You see the arrows are crisscrossing. So I want to talk about one of the words that you'll see here called uplift. Uplift is a natural process by which rocks that are formed below the Earth's surface get pushed up towards the Earth's surface. And when they get pushed up towards the Earth's surface, they can form things like mountains. For example, the picture that you see above you right now. Okay, these mountains, these rocks, now get exposed to the atmosphere. And once they become exposed to the atmosphere, they become part of another process, which we call weathering. Now, we'll do a whole PowerPoint about weathering, but weathering is basically the breakdown of rocks. Like you see in the rock in front of you right now, that's cracked in half. The rock did not form like that. The natural processes of the earth did that to it. So, once again, uplift is this process by which rocks get lifted up to the surface. Exposure is when rocks are now subject to the wind and the water and the weather. And then weathering is the process by which rocks are broken down. Okay? And once you break those rocks down, those pieces can get transported, which means they get moved, through a process called erosion. So erosion is the movement of weathered rock, and eventually dropped off in what we call deposition. Deposition was when you drop the pieces off. These little pieces of pre-existing rock are what we call sediments, and they're going to play an important role in the next thing we're going to talk about. All right, so now you have the sediments. So what do you do with them? You lay them down, and then you drop some more on top, and then you drop some more on top. And as you keep dropping more and more and more layers on top, as you keep depositing more and more layers, they get squished, or what we use in science, the term compaction. So you basically compress them and compress them and compress them and compress them and compress them until you go from these pieces of pre-existing rock to a new type of rock. This process by which you go from pieces to a new type of rock is what we call lithification. Lithification is the process by which you go from a sediment, which is a piece of pre-existing rock, to a sedimentary rock, which is the rock that you guys have seen before that usually has lots of layers in it. Now, the sedimentary rocks can be formed by lots of different things. They can be formed by glaciers, they can be formed by rivers, they can be formed by wind. Okay? But they're basically just layer upon layer of pieces of pre-existing rock that you smush together to make a new type of rock. Now, as you can see in the chart, you can double back, and these rocks can get uplifted and exposed and weathered, and then the process can happen all over again. So it's not like it's a direct circle, but there are these general paths that we can take, but always remember there's these little forks in the road that we're going to talk about. And so this process creates sedimentary rocks. Now, those sedimentary rocks, and igneous rocks as well, can sometimes get buried under layers upon layers of sediment or other rocks and pushed deep down beneath the Earth's surface. Now, we all talked about this. The deeper you go down inside the Earth, what happens to your heat and what happens to your pressure? It goes up. Now, if you put a rock under enough heat and pressure, it actually won't melt or break. As you get pushed underneath the Earth's surface, your rocks start to become a little bit flexible. We use the term plastic in that they're bendable. Okay? And what'll start to happen, and we'll talk about this in more detail in a couple of weeks, is that the rocks can change. Their chemical structures can change. Atoms can get added in, atoms can get taken out. The heat and the pressure can change the appearance, the properties, the hardness. Okay? All these things can change, and you can become an entirely new type of rock. Now, what do we call it when you change from one shape to another? You learned this when you learned about butterflies. What do butterflies go through? Metamorphosis. What do we call it when a rock goes through this? Metamorphism. Metamorphism is when a rock changes because you apply extra heat and extra pressure. What do you get when you put a rock through metamorphism? A metamorphic rock. Now, the key thing is a metamorphic rock used to be another type of rock, and it was heated and squished. Not to the point that it melted, but to the point that it changed. It could be any type of rock. It could be a sedimentary rock. It could be an igneous rock. It could be another metamorphic rock. Now, metamorphic rocks, like the one you've been seeing on the screen for a while, have a bunch of different properties, and they're very interesting and very unique. We find a lot of them actually here in New York. Now, if you push a rock, any rock, too far, it will melt. What does melt mean? It means you go from a solid to a liquid. And what have we done? We've started the process all over again. So what do we call a process that repeats over and over again? A cycle, which is why we call it the rock cycle. All right, guys. So that is all for today. Here's a lovely picture of the brand new addition to the Gonzalez family to remind you guys to study hard. There will be homework on Google Classroom. Make sure you turn it in. If you have any problems, make sure you email it to us. Bye, guys.